Aloha and welcome to the third module of the Eyes of the Reef Network online training program. Thanks for being here and taking the time to learn more about how you can help protect Hawaii's coral reefs. The third module of this training will provide you with an overview of coral bleaching, including causes and how to recognize bleaching at your local reefs. If you have any questions during or after this training, please reach out to your local island coordinator for more information. Free training materials are available for you or your class, including underwater guides and training booklets. Please reach out to your local island coordinator to find your nearest pickup location. Contact information can be found at our website at eorhawaii.org. In this module, you will learn more about coral bleaching, including causes and how to identify bleaching at your local reef. We'll also discuss the importance of climate change and its role in driving regional scale coral bleaching events across the globe. Corals are taxonomically classified as animals, but contain microscopic plant cells in their tissue. This is a vital characteristic of reef-building corals. Healthy corals must contain plant cells, called zooxanthellae, to ensure their long-term survival. Coral reef areas are often nutrient poor, and corals must obtain energy through photosynthesis, in addition to consuming plankton, to maintain all of their nutritional requirements. The association between corals and their plant cells is an obligate mutualistic symbiotic relationship. This means that coral and the zooxanthellae require one another to survive and thrive, and both ultimately benefit from the relationship. The coral polyp provides a protected home for the zooxanthellae within its tissue. You can see the tiny plant cells within the translucent coral tissue in the images. As the coral respires and consumes food, it also provides both fertilizers and carbon dioxide to the plant cell. Zooxanthellae do what all plants do, photosynthesize. By harvesting energy from the sun and waste products from the coral, zooxanthellae provide glucose, glycerol, amino acids, and oxygen back to the coral. Importantly, plant cells can provide up to 90% of the coral's diet. The presence of zooxanthellae in a healthy coral is indicated by the coral's color. The deeper the color, the more zooxanthellae live within the coral tissue. So what exactly is coral bleaching? Understanding the role of zooxanthellae in a coral colony is an important building block for understanding coral bleaching. Coral bleaching occurs when zooxanthellae are expelled from a coral polyp due to stressful environmental conditions. Extended exposure to high water temperatures is the primary cause of large-scale coral bleaching events, like the one we experienced in Hawaii in 2015. After zooxanthellae are expelled from a coral, you can see all the way through to the coral's translucent tissue, to the white skeleton below. From a distance, a bleached coral can appear to be bright white. In this image, a red rice coral is partially bleached. Please note that coral bleaching has nothing to do with the application of chemical bleach, despite the use of this confusing term. Fortunately, corals can survive in the bleached state for a limited time, depending on the extent and duration of the elevated seawater temperatures. If water temperatures return to normal within days or weeks and the coral stress level subsides, a bleached coral can often return to a healthy state and regain normal coloration. A bleached coral can survive for days, weeks, even months in some cases, but eventually, if water temperatures remain elevated, the lack of photosynthetic energy overcomes the coral's ability to survive. Remember that the food created by zooxanthellae can comprise up to 90% of the coral's diet, so a lack of zooxanthellae can eventually cause starvation of the coral. The image on the far right is a previously bleached reef, now overgrown with algae, indicating that the coral did not survive the event due to prolonged temperature stress. In recent years, seawater temperatures have been seasonally very high when compared to maximum temperatures over the past several decades. Unfortunately, due to increasing atmospheric carbon emissions and resultant climate change, sea temperatures are forecasted to continue to increase in the coming years and decades. Many of you may have witnessed coral bleaching in your area of Hawaii sometime between 2014 and 2017. During this time, Hawaii experienced severe coral bleaching in some areas, along with many other reefs around the world, including the Great Barrier Reef in Australia. This almost 4-year event was described by NOAA as the third recorded global oceanic warming event, and it was the most widespread, longest, and possibly the most damaging coral bleaching event on record. It was also the cause of extensive coral mortality globally. Until recently, coral bleaching was limited to uncommon and localized events in the main Hawaiian Islands. In the northwestern Hawaiian Islands, the first recorded mass coral bleaching event occurred in 2002. Beginning in 2014, a massive regional scale coral bleaching event occurred in some areas of the state, including the northwestern Hawaiian Islands, Oahu, Maui, and Molokini, and West Hawaii Island. This event was followed by a less severe coral bleaching event in 2019. Unfortunately, up to 50% of coral cover was lost in some areas due to these recent bleaching events. During these events, researchers learned that certain types of corals are highly susceptible to bleaching, including small branching corals and certain species of smooth mounding corals. Managers have carefully documented signs of reef recovery since then and have begun statewide efforts to promote reef resiliency and recovery. In the next few slides, you will learn how to identify and report coral bleaching. When you submit a bleaching report to the Eyes of the Reef Network, you will need to indicate the severity of coral bleaching that you are observing. The options you will have to choose from are 1. Mild coral bleaching or paling, 2. Partial or patchy coral bleaching, or 3. Severe or bright white bleaching. In this image, partial pale bleaching is occurring on this red rice coral along the outer edge of the colony. For comparison, non-bleached areas of coral can be seen around the center of the colony. Early signs of coral bleaching can be subtle, including just a slight loss in coloration known as paling. To identify this condition, it helps to get familiar with the normal coloration of corals in your area. Coral bleaching may happen gradually as the coral colony begins to experience warmer water temperatures in late spring and early summer. Generally, the most severe bleaching occurs in the fall when water temperatures are at their warmest. More severe, partial, or patchy coral bleaching is identified as large white sections of bleached coral on a single colony, as shown in the image on the left. White bleached coral sections are surrounded by non-bleached or pale coral sections. And finally, the most severe type of coral bleaching can be identified as a completely white coral colony with almost no signs of color or pigment, as shown in the image on the right. Note that some corals, such as blue rice corals, sometimes have additional pigments in their tissue, so when they experience bleaching, they may exhibit bright iridescent colors. These iridescent bleached corals also fall under the most severe bleaching category. As you will continue to learn throughout this training, many of the impacts to corals result in white patches along a coral colony. Oftentimes, the cause of a white condition can be difficult to distinguish. The best way to know if you are observing coral bleaching is to look for tiny tentacles along the coral surface. Bleached corals are still alive, and live coral polyps will be visible when the colony is observed up close. In the lower right image, tiny tentacles are visible along this bleached rice coral colony. The recent loss of coral reefs globally due to bleaching events and other stressors has many people wondering what they can do to help. There are many ways you can get involved in supporting coral reef conservation, including taking steps to reduce your own carbon emissions in daily life. For more ideas on how to help protect coral reefs, please visit the NOAA Coral Reef Conservation Program website at coralreef.noaa.gov. To learn more about coral bleaching, please visit our website at eorhawaii.org/education. We also recommend visiting the NOAA Coral Reef Watch webpage for the most current information on sea temperatures and to sign up for bleaching alerts in your area. Please visit coralreefwatch.noaa.gov for more information. This concludes Module 3 of the Eyes of the Reef online training program. Mahalo for your participation. Next, you will be required to successfully complete a short review quiz in order to move on to the next module. Okay, question 1. If a coral colony is white in color, it is definitely bleached. A, true, or B, false? If you selected B for false, you are correct. Okay, question 2. What is coral bleaching? And you can select all that apply here. A, the white skeleton of a coral colony becomes visible through transparent tissue. B, a change in colony color, typically paler white, as a result of loss of algal symbionts, which would otherwise determine colony color. C, bare white coral skeleton that has lost its tissue. D, a condition from which corals cannot recover, always leading to death of the colonies. And E, a condition indicating high stress levels due to environmental conditions from which a coral can recover if undesired conditions cease. If you said A, B, and E, you're correct. Question 3. To determine if a coral colony is white due to bleaching, look closely for A, damaged coral skeleton in the shape of a bite mark, B, transparent coral polyps and tentacles, C, white coral skeleton separating live, colorful tissue from sections of coral skeleton with algal growth present, or D, all of the above. If you said B, transparent coral polyps and tentacles, you're correct. Okay, last question. The primary cause of regional scale mass coral bleaching events is A, changes in salinity, B, prolonged high sea temperatures, typically in the late summer and early fall, C, pollution and poor water quality, D, exposure to non-reef safe sunscreen, E, sedimentation, or F, none of the above. And the key word in this question is regional scale. So what causes mass scale coral bleaching events? And if you said B, prolonged high sea temperatures, typically in the late summer and early fall, you're correct. Okay, how did you do on the quiz? If you missed more than a few questions, you might want to go back and review the materials in this module before moving on to Module 4. Mahalo for your participation in our online training program. In the next module, you will learn more about diseases of corals and other marine organisms.